Okay, so apologies. I've been having some difficulties with the technology, so I'm going to try and explain a more advanced type of trigonometry equation, um, and that's when you've got something going on inside the bracket here, like a 3x or a 2x, or even like we've got here a 2x plus 30 or something like that. I'm going to give you the quick version because basically I just recorded a half-hour video and I lost it. So, right, the quick version is there's a method for solving these, and there's sort of 4 steps really. First step, we make a substitution. Second step, we change the range. Third step, we solve, and then fourth step is we undo the substitution. Basically that's what we're going to do. So in order to make this less scary, the first thing we can do is instead of having 2x here, we just make it into a y. So now we're just solving sine y equals a half, which is easy because we've done that before. But we don't get away that easy because there is a catch. If you're going to make a substitution, you have to change your range. So this is the range here. If it's a 2x, we're going to have to double the range. If it's a 3x, we're going to have to triple the range. So our new range is going to be, well look, here's 0. We're going to have to times that by 2, which is still 0. X times 2 is 2x, and 360 times 2 is 720. So as long as what was in here, 2x, is now here, 2x, you know you've done it right. So you can see a 2x there, you got a 2x there, you've got your right range, times everything by 2. And this is of course also equal to y now, because we said y is 2x. So now we're going to solve this equation sine y equals a half, but in the new range. So quick sketch of sine, just a reminder, does up to 360, but the new range means we have to go twice that up to 720, and we're interested in a half, so half is kind of here. So we're going to expect to find 4 solutions, 1, 2, 3, 4. And using the methods that we already know, we can find those quite easily, hopefully. So we do inverse sine of a half, and we should get on the calculator y equals 30. So that's this first one here. Because the rule with sine is you do 180 minus your answer, this one is going to be 150. And then remember, to get the other two, you just add 360 to what you've got. So 30 plus 360 is 390, and 150 plus 360 is being lazy, terrible arithmetic, 510. So those are answers for y's. Final step, undo the substitution. Now basically what that means is, since y is also, since we said y is 2x, 2x is 30, 150, 390, 510. So x is just half of all of those. So 15. 2x is 150, so x must be 75. 2x is 390, so what was that, 195? And 510, divide that by 2, 255. And that will give us all our answers. And on your graphics calculator, you can actually check this. And if you're doing the calculator paper, you can do this on your paper. What you do is you type in, you go onto graph mode. I can't show you this, unfortunately, but you go into graph mode and you type in y equals sine 2x. And then on the second line, you should try this. You type in y equals a half, and then you get the graph up, and the graph should look like a little bit different because it will be a transformed version. It will be y equals sine 2x. So everything will be squashed, and you'll have two lines. You'll have the sine, and you'll have the line where it's a half. And if you go for gsolve, and you look for intersections and you click between them, you should be able to get those 4 intersections there, and you should find that it's the same 4 answers. So can you try that on your calculator? But of course you need to be able to do it both ways because there's a non-calculator paper as well. But that's the basic method. So I'm just going to do that method again on this second example to show you, just so you feel more comfortable with it really. But it's the same thing. So let's see. Yep, okay. So step 1, substitution. This time y equals 3x. So now we're solving cos y equals 0.2. We've got to change the range though, because we don't get away with it. It's quite so easy. This time you'll notice the range is in radians. We're going to have to times everything by 3 to get our new range. So minus 3 pi 3x. Sorry, that's supposed to be one of those. And 3 pi times everything by 3. Now the 3x is here and it's also here, so we know we've done it right. Just quickly rub this bit out because it wasn't equal to, was it? It was just strictly less than. That's the new range. Solve. We're solving cos y is 0.2. Grab the calculator, put it into radians mode. Inverse cos 0.2. 1.37. So y equals 1.37. Quick sketch of the cos graph. Let me just do it better. Quick sketch. Graph of cos. Normally looks like that. That's 2 pi. But we need to go into our new range, so we need to go all the way to 3 pi, which will be down here. And we need to go into the negatives as well. So that's minus 2 pi. And that is minus 3 pi. So I did this cos graph, but I just extended it in both directions to fit with the new range. And we're looking for 0.2. This is kind of expecting to find answer here, here, and here, and also the negatives. So we got one of them, 1.37. How do we get the others? Well, it's standard. It's like we did last week. Cos being symmetrical about in a certain way, you can just do 360 minus, or in this case 2 pi minus 1.37, 4.91 for this one here. And then it starts to repeat, so we just do 2 pi plus the original answer, 7.65. And you can look at the graph and see, look, the whole thing's symmetrical anyway, so the other answers are just going to be the negatives of the ones we've already found. So minus 1.37, minus 4.91, minus 7.65. And then the final step, undo substitution. Y is 3x, so to get x we'd have to divide all those answers by 3. So let's just do that. 0.457, 4.91 divided by 3, 1.64, 7.65 divided by 3 is 2.55, and the other ones are going to be the same but negative. It's the same numbers. So minus 0.457 minus 1.64 minus 2.55. So that's the answer. Again, you can do that directly on your graphics calculator by getting up this graph and also getting up y equals 0.2 and solving them simultaneously using the GSolve. But again, that's only going to be useful if you're on the calculator paper. Yeah, so you kind of need to know both ways. Okay, finally, going to do a slightly harder one. Tan squared 2x plus 30 is 2. X is between 0 and 180. Now I just wanted to show you what happens if you get a squared. What you do is you remember that tan squared, what that means is, all that is it's just tan of that thing, 2x plus 30, all squared. And that means we can just root both sides and get rid of it. Kind of get rid of it. Plus or minus root 2, and that kind of makes it a bit less intimidating. But it's annoying because we've got that plus or minus. And you will see what difference that makes in a sec. So solve this. Let's do the steps. Substitution. Y equals 2x plus 30. So now we're solving tan y equals plus or minus root 2. Okay, that's a relief because I didn't like that 2x plus 30. But we do have to change the range, that's step 2. So we basically times everything by 2, add 30 to everything. So 0 times 2, add 30 is 30. X times 2 is 2x plus 30. And 180 times 2 is 360. Add 30 is 390. So basically we're now solving this in this new range. Okay, not, it's kind of a little bit annoying, but it's not too bad, it's not too horrible. So, quick sketch of tan. Tan looks like this, that's half of it. Then you repeat for the other half. 360. We're supposed to go to 390, so I'll just go a little bit further. 390. And we can actually cut it off at 30 because that's everything on this side is outside of the range. So we're looking for solutions, but this time it's plus or minus. Okay, so the important thing about this is, let's just have a look. What's root 2? It is about 1.41. So 1.4, so look, root 2, 1.4. We're expecting to see 2, maybe 3 solutions. But the thing is, you also have to look for minus root 2 because the answer is plus or minus. So there's actually a couple more solutions here to fully solve it, because tan y can be plus root 2 or minus root 2. So that's the little trick there. Okay, so we solve. So change this, solve. Y equals inverse tan of root 2. .955. Okay, the brilliant thing about tan, you'll remember, of course. Oh, hold on. Sorry, I did that in the wrong. It's supposed to be in degrees, wasn't it? See, very easy to make that mistake, isn't it? I was in radians. So look, y is 54.7. Remember the nice thing about tan, just add 180, get your next solution. let's add another 180, see what comes out. 414, too big, it's outside of the range, because the range goes up to 390, so ignore that. And there's those other ones where it's negative root 2, so we'll do it again, inverse tan, negative root 2. I've typed it in weirdly. Okay, minus 54.73. Okay, that's outside of the range. The calculator gave us this bit here. So, but anyway, it doesn't matter. Just add 180, put it back inside the range. 125. Add another 180. 305. That must be this one here. 305. That must be the 125. And this one must be the minus 54, which we don't care about. So, nearly there. Now, let's just check. We got, yeah, cross that one out. So we got those 4. Final thing, undo the substitution. And that is simply so. Now we know that 2x plus 30 is all of those. We just do a linear equation. Just write them out again. So x must be, we'll take 30 away and divide by 2. That will solve it. 54.7, take away 30, divide by 2. 12.35 degrees. 234, take away 30, divide by 2, 102. 125, take away 30, divide by 2, 47.5. And 305, take away 30, divide by 2, 137.5. That should be the answer. And again, you can check that on your graphics calculator by typing in this part, y equals this, and y equals this. 2 separate lines, and then doing gsolve and finding the intersections, and you should find they come out the same. So have a go at doing that, and let me know if it doesn't work. So just give you this as a recap. That's what we've done so far, and that should be enough to allow you to do those questions which I've set. Okay, thanks guys, I'll see you next time.